the next technique is distillation. So distillation is used when the product is the actual liquid that is soluble in the solvent. So this is when the product is soluble in the solvent, so you can't see, like, you can't distinguish between the two liquids. So for extraction, because the two solvents were immiscible, they didn't mix. You can see like where they separated from each other. But this distillation is used when the liquid that you want is mixed in with a different liquid that you don't want. So you have to use this method of distillation in order to separate the two. So distillation, it utilizes differences in boiling points to separate the liquids. So this is done through evaporation and then condensation. So the mixture to be separated is placed in a distilling flask and then heated using a heat source. So as you can see on the picture on the right, the distilling flask, this will contain the liquid that you're interested in, and then also whatever solution that it's mixed in. You have a heat source on the bottom that heats up the flask and boils the solution. And there will be a thermometer attached because you want to monitor the temperature. So when you're separating the two liquids, you will have to know the boiling points of the liquids that you're that's in distilling flask. So you want to know the temperature because since there is a difference at boiling point, if the liquid that is distilled at like 37 degrees Celsius, you will know what liquid that is. But when another liquid is boiled at like 80 degrees Celsius, that will be a different liquid. So you will know that there's a difference between the two liquids based on the differences in boiling point. So like I said, this is done through evaporation and condensation. So once you evaporate the liquid, it will go through this condenser. So this condenser is basically something that cools down the vapors of the liquid that you just boiled. So once it is cooled, it will condensate and then it will drip down into this receiving flask. So this is basically the general mechanism behind distillation. Because the liquids in the distilling flask have a difference in boiling point, you can boil the solution, and the first liquid that comes out will be one distinct product, and then anything after that will be a separate liquid that boils at a different temperature. So the thermometer is important because you have to monitor the temperature at the temperature that the liquids come out in. The differences in boiling point is the deciding factor on like what the liquid comes out, what the identity of the liquid comes out is. So like I said before, the liquid with the lower boiling point will vaporize first. The vapors will rise up into the distillation column and into the condenser that is cooled by cold water, and the condensate will drip into the vessel, and that condensate, the liquid that comes out, is known as the distillate. So the temperature is kept low because you want to monitor the temperature, and you want to increase it slowly because the liquid with the higher boiling point, you want to ensure that it doesn't boil and remains a liquid, because if the temperature goes up too fast, both the two different liquids will boil at the same time, and you won't be able to distinguish the difference between the two liquids. So distillation, as it's boiling, you'll collect the condensate, and the first condensate that's collected will be a a distinct liquid, and then as the temperature rises, it will stop boiling the first liquid, because it will all have been boiled and drip out as condensate, and the liquid left over in the distilling flask will be the other liquid with a higher boiling point that hasn't boiled yet, and will remain in the distilling flask until the temperature rises to that boiling point, and then it will come out as a condensate as well. So a key thing for distillation is you want to prevent super boiling. So this is when you heat the liquid too fast. It's heated above a temperature. It is heated to a temperature above the boiling point without vaporization. So this is when the temperature is heated up too fast, too high, and the liquid is above its boiling point, but nothing is boiling. So this is because the gas bubbles in the liquid are unable to overcome the atmospheric pressure and tension. So the solution will be at its boiling point, but not boil. So this is known as super boiling. And in order to prevent that, we use a boiling chip or a magnetic stir that you put in the distilling flask that basically just swirls around in the distilling flask, or known as, there's also another thing known as an ebullator. These are used to break the surface tension and prevent super boiling. So it moves around in the liquid to break surface tension and prevent super boiling. This is important because if it gets too hot, the whole distilling flask will shatter, and your experiment will be ruined, because this whole technique is based on boiling the liquid. So the different parts of the distillation technique: the distilling flask contains that combined liquid solution with the desired product mixed in with other solvents. The distillation column, it consists of the thermometer and condenser. So the thermometer is used to monitor the temperature of when the solutions boil. The condenser is used to cool the vapor and funnel it into the flask. And then the receiving flask on the other end will collect the distillate that evaporates and then condenses. So that first method I explained was known as distillation. There's a few different distillation techniques. So simple distillation, basically that technique I mentioned, this is used to separate liquids that boil below 150 degrees Celsius and then have at least a 25 degrees Celsius difference between the boiling points. So you use this when you want to boil liquids that have a boiling point below 150 degrees Celsius, and there's at least a 25 degrees Celsius difference between the boiling points of the liquids. So this is used below 150 degrees Celsius because you have to prevent the temperature from becoming too high, because when the temperature becomes too high, it'll degrade the compound, or the second compound that you don't want will boil off into the distillate, because there is not a large enough boiling point difference between the two liquids. So you have to keep it below 100 degrees Celsius, and the two liquids must have at least 25 degrees Celsius difference between their boiling points. So that's simple distillation. There's another form called vacuum distillation or column distillation. So this is used to distill liquids with boiling points above 150 degrees Celsius. So simple distillation has to be below 150 degrees Celsius. When the boiling points are over 150 degrees Celsius, you have to use vacuum distillation. So a vacuum is attached to a setup The vacuum is used to lower the ambient pressure to decrease the temperature that the liquid must reach to have sufficient vapor pressure to boil. So as you know, boiling is when the vapor pressure is greater than the ambient pressure. So the vacuum will lower the ambient pressure in order to decrease the temperature that the liquid has to reach. So basically, it will decrease the temperature needed to boil the solution. So this is good for any liquids with boiling points over 150 degrees Celsius, because if you boil over 150 degrees Celsius, the other compounds might degrade before reaching that boiling point. So vacuum distillation used for any liquids over 150 degrees Celsius. This is to allow the compounds to distill at lower temperatures, even though their boiling points might be higher. So that's vacuum distillation. And lastly, there's another form called fractional distillation. So this is when the liquids have similar boiling points. So the boiling points are less than 25 degrees Celsius apart. So because the boiling points are too similar, simple distillation and vacuum distillation won't be able to separate the two. So you have to use fractional distillation. So fractional distillation, it involves a fractionation column. So it's this long column in the middle with the little ridges in the center. So the fractionation column connects the distillation flask to the condenser. So it's basically simple distillation, but just with this extra column attached. So the fractionation column, it's used to increase the surface area to separate the liquids better. So this column will be able to separate the liquids in the distilling flask, even though they have boiling points that are less than 25 degrees Celsius apart. So how this works is when the vapor rises up the column, it condenses on those surfaces in the fractionation column and refluxes back down until the heat causes it to evaporate again and then condense again. But once it condenses higher in the column. So basically, it's repeated rounds of evaporation and condensation until it reaches the top of the fractionation column and then goes into the condenser. So this repeated evaporation and condensation, this is in order to separate the two liquids that have similar boiling points. So the vapor has a higher proportion of the compound with a lower boiling point each time the condensate evaporates and then condenses again. This is because the compound with a higher boiling point, it will take longer for it to boil and reach the top of the fractionation column, while the compound with the lower boiling point, it evaporates faster at a lower temperature. So it will evaporate more and condense higher in the fractionation column. So at the end, only the desired product with the lower boiling point will drip down the condenser and into the receiving flask.